Are you good?
Yeah.
All right, so here's what we need to do. What does number 1 say on our lab? What does number 1 say on our lab? What's number 1, Dallas? What's number 1 on the lab? What's number 1 on the lab, Mateo?
With your lab group, stretch the slinky between two people on the floor. Measure the length of the outstretched slinky.
Okay, so this has to be constant the entire time. Okay, so whatever they're doing has to be constant. That means it's not our variable. So no matter what, each time we're going to have to make sure that it's this distance. Okay, it can't be stretched any further. So from his hand to Grace's hand. That one. So every single time, we need it to be 140 centimeters. So I'm going to write that on the board. So that is, and that's number 1. That's 140 centimeters. So number 1. Every single time, we need to make sure that it gets to 140 centimeters. Remember, what is the only thing that can change in a scientific lab? The variable. Okay, and that is going to be our amplitude. Okay, so we need to make sure it's level. So it looks like you need to go. You can go up. Well, I want it to be exactly 100 centimeters. So, okay, perfect. So now one person is going to move it. And I want it to be Grace. Grace, just carefully move it, and I'm going to try to see how much an amplitude it's changing. Okay, so move it a little higher to try to hit my hand. Okay, so that is how high it's going. Okay, so keep it the same level. Now I need one other volunteer to run the stopwatch.
Wait, it has to be somebody that hasn't done it yet. Evan.
Who is not Evan? Come on up, mask up. So here's the thing. Here's what you're measuring. So each time, remember it's got to be flat. Okay? So each time you are going to, I'm going to have my hand here. So you need to go down. So I'm going to have my hand here. When it starts hitting my hand, you are going to calculate how long it takes for it to hit my hand 3 times. Does that make sense? 3 times. Okay? Oh, I'm sorry. Seconds. Number 1. 2.03 seconds. And I had it what? I probably had it probably right there. All right, so it's 100. Let's call that 30 centimeters. So number 1 was 2.03 seconds and 30 centimeters. Okay? So that would be 0.3 meters. No, because we're doing it from the resting position. We're doing it from the resting position, which is 100 centimeters. So we have to divide 30 by 2.03 to get our meters per second. Who can do that? Where's your calculator? Okay. divided by 2.03.
It's gonna come out. Oh, that's a lot of numbers.
Well, give me point what? 0.15. All right. So now I want our amplitude to go up by 20. So we need to. Yes. So I want it to go up 50 centimeters from there. All right. Once again, Evan is going to. Two 2.12, and this was 0.5 meters. And what is that? So 0.5 divided by 2.12. 0.225. 235. I'm sorry, 235. So, wasn't there a I might have gone ahead of myself. Number 2, we got to figure out what kind of wave this is, right?
Oh, it's a.
What is it?
Is it a longitude movie?
No, it's going up and down. So it's going perpendicular to the medium, which is what? Transverse. Okay? So it's transverse, right? It's going up and down. Perpendicular with the medium. Okay, now I want to go 70 centimeters from our resting position.
Oh my gosh.
Wow, that is a lot. You dropped the book.
Okay,
Yep, I did.
here we go.
Oh.
Evan, Grace,
Yes.
are you both ready?
Yes.
Okay, ready, set, go. 1, 2, 3. Okay,
3.75.
3.75. Now, I do want to say there's a little bit of human error that's going to be involved in this, and that's not a big deal, because we're going to do a simulator with this exact same thing. So this is second still. And then this was 0.77 meters. And Alex, what's that? 0.7 divided by 3.75.
Oh, wow. 186.
0.186. All right, my volunteers, thank you.
Would you like
I'll take the slinky back.
I was
So-
a volunteer, of course.
Now, let's discuss human error. See, and I think we're good.